Hello friends, welcome to the second video on Stokes theorem. This problem will verify Stokes theorem for the f vector y minus z plus 2 times I, y z plus 4 times j minus x z k, where s is going to be an open surface of the cube which is formed by x equal to 0, x equal to 2, y equal to 0, y equal to 2 and z equal to 2. So what is missing over here? The missing part is z is equal to 0. So a cube has 6 faces. Out of the 6 faces, which face is missing? Z is equal to 0 is going to be missing. Okay. So we were to verify Stokes theorem. Let us first write the statement for the Stokes theorem. Integral over C f vector dot dr vector is equal to double integral over S your del cross f vector dot n cap ds. Okay. So we will have to evaluate our left hand side separately. We'll have to evaluate our right hand side separately and show that they are going to be the same because we'll have to verify Stokes theorem. So we will begin with the dimension first. The first value goes for the formula. The second value now goes for your diagram. Okay. So this is going to be the visualization of the cube. The cube is going to be along x, y and z axis. The cube is going to be made of 6 faces. So what are going to be the 6 faces? You have a front and a back. You have a left and a right. And you have a top and a bottom. Okay. So the back portion is going to be z over y. So you call it as x equal to 0. Front portion is x equal to 2. The x over y is going to be y equal to 0. So this will be y equal to 2. And the top value will be equal to the bottom value is x z y. So this is going to be z equal to 0. And so the top will be z equal to 2. So now you will have the unit outward drawn normal along the directions of x to be equal to I in minus I, and this will be equal to j, and along the other value left it will be minus j. To the top it will be k, and to the bottom it will be minus k. Now what has been done? The lower portion, which is z is equal to 0, has been cut open for us. When it is being cut open, you have an open two-sided surface. So now this will be bounded by the square over here at the bottom. Now we will begin with the right hand side. What is going to be the right hand side? Del cross f dot n cap ds has to be evaluated for double integral s. Now one of the face y equal to 0 has been cut off from the 6 faces. So how many faces are left out? We have 5 faces to be left out. What are they? X equal to 0, x equal to 2, y equal to 0, y equal to 2, and the top portion z equal to 2. So now I'll have to evaluate my double integral over S for all these 5 phases. So for these 5 phases, I'll have to evaluate first what is del cross F. Then multiply with the dot product n cap ds. Okay, so now let us compute what is going to be del cross F. So this is going to be I, j, k, dou by dou x, dou by dou y, dou by dou z. What is the value of F? F in the x component is y minus z plus 2. And this will be yz plus 4, and this is going to be minus xz. So we are going to compute the 3 cross 3 determinant for it. Copy your f, y minus z plus 2, yz plus 4 minus xz. Okay, so now you can evaluate the 3 cross 3 determinant. I times of dou by dou y of minus xz minus dou by dou z of yz plus 4. So this is my A component, minus j times of j component is dou by dou x of minus xz minus dou by dou z of y minus z plus 2 plus k times of the k component dou by dou x of yz plus 4 minus dou by dou y of y minus z plus 2. Now let us evaluate this partial derivative. So it is going to be I times of what will happen? There is no y component here. So this will become 0. With respect to y, I have it as minus y. Minus j times of what is happening over here with x? You have minus z. What is happening with z? You have minus z. So this is minus 1. Okay. So you have a minus sign outside. Minus of minus will make it as plus 1. Plus k times of what will be the derivative over here with respect to x? no x. So this will become 0. What will be this with respect to y? You have y here. So it is going to be minus 1. So the total value of del cross f is minus y I. Let me take this minus inside. So this will become z minus 1 times j minus k vector. So this is my del cross f. Now I will make use of this del cross f for the phi surfaces. So what is integral, double integral over s? I am going to split it as s1, s2, s3, s4 and double integral over s5 for the 5 different phases which I have over here. Let us tabulate them. Front, back, right, left, top. Equations are 2, 0, 2, 0, 2. Unit vectors are I minus I, j minus j, k. Now what is going to be my del cross f? Let us copy paste our del cross f from the last page. So what is over here? Minus yi plus z minus 1 times j minus k. Now this has to be taken dot product with n cap. So what is my n cap? This is going to be my n cap. My n cap is over here. So what will happen? I know the quantity that I dot I is going to be 1, j dot j is 1 and k dot k is 1. All the other remaining mismatch combinations will give me 0. So when I take I into I have this as minus y. I into minus I, so this is minus into minus plus y. J dot j will give me z minus 1. What will be minus of j dot j minus of z minus 1? What will be k dot k? This will be equal to minus 1. So my values for del cross f dot n cap has been got. Okay, so now what happens over here? Now we can. So now by substituting all these values, we will try to put the equation back over here to get the value. No x for substitution, so this remains as minus y. No x for substitution, so this remains as y. No y for substitution, so this remains as z minus 1. No y for substitution, so remains as minus z minus 1. And no z for substitution, so it remains as such. If there is going to be variable x, y, z, you have to replace it with the corresponding values. Now you can go for the integration for your surface. So don't directly go for your integration step by step, but what you can rather do is club the quantities, because what is common over here? Dy by dz. So when I club my s1 and s2 together, what I will have is minus y plus y of dy dz. So this will cancel off with one another, leaving you with value 0. When I club my S3 and S4, what will happen? I will have Z minus 1 minus Z minus 1. With respect to what is going to be the derivative? It is dx dz. So the surface is dx dz. So this cancels off again 1 with respect to other, so leaving you with 0. So what is the only quantity to be evaluated for the surface now? It is double integral over your S5. The quantity is minus 1 dy dx. So now we will go on for the evaluation. So double integral S has now reduced to double integral S5. The quantity to be evaluated is minus 1 dx dy. You have been evaluating for a cube. What is your cube bounded by? X equal to 0, x equal to 2, y equal to 0, y equal to 2, z equal to 2. Okay. So I want the limit for x and y. What is the limit for x and y? X varies between 0 to 2. Y also varies between 0 to 2. Now what I will have to evaluate? Minus 1 dx dy. Minus 1 is a constant. Dx on integration is x between 0 to 2. What is dy on integration? Y between 0 to 2. So this makes it as minus 1, 2, 2. So that makes it as minus 4. So this is going to be my RHS. So I have evaluated the RHS. What is now left? Your LHS. So how to get your LHS? Go back to the Stokes formula. Integral over C f vector dot dr vector is double integral del cross f n dot ds. Left hand side is still bending. RHS is over. Integral over C. What is my C? When I remove one of the surface, then you will have a two-sided quantity leaving you with a boundary C. Which is the quantity removed here? this z equal to 0 is removed. So when I remove this z equal to 0, what you will be having is the curve C along which you will have to travel. So what is this curve C? This is what is your yellow portion showed over here. So how to label them? You can label them very easily. Z, O, Y. So this is going to be my back line. What is the back line? Z, O, Y. What is the equation of Z, O, Y? X equal to 0. Okay. So what is in front? How many units we moved? 2 units. So this is X equal to 2. What is this line? XOZ. So this line XOZ is formed by the name Y equal to 0. How many units did we move in Y? 2 units. So this is the line Y equal to 2. So we have got all the equations. So what is the next thing? To find the coordinate. All the coordinates are got by the ordered pair X comma Y. Go for labeling O, A, B, C. This curve has to be traversed in anti-clockwise direction. Keep it in mind. So the cycle integral over C is going to be OA, AB, BC plus CO. So you are splitting it into 4 parts. The first coordinate for O. How is O got? X equal to 0, Y equal to 0. So 0, comma 0. How is A got? X is 2, Y is 2. Okay, so 2, comma 0. What is B coordinate? 2, comma 2. What is C coordinate? X is 0, Y is 2. So 0, comma 2. All my coordinates are got. Now I will have to evaluate the integral. What is going to be the integral over here? F vector dot dr vector. What is our F vector? So let me write my F vector. F vector is given as y minus z plus 2 I plus yz plus 4 times of k plus minus xz times of, sorry, this is going to be k and this is going to be equal to your j vector. Okay, so now you have your F vector. Okay, where is this F vector? This is formed above the z equal to 0 plane. So this is the one which we cut off. Okay, so z equal to 1, the 0 plane, this is going to be our z equal to 0 plane. When z equal to 0, what will happen to my F vector? Now this will get reduced to the simplified form. Substitute z as 0. So this will become 0, this will become 0 and this will become 0. So what will be left out of my F vector? My F vector will be left out with y plus 2 times of I. This has gone plus 4 times of j. There is no k component. Okay. So I'll have to take the dot product with what? Dr vector. What is my dr vector? My dr vector is dxi plus dyj plus dzk. Now, what do we know over here? This is z equal to 0 plane. So, what will be dz? Z equal to 0 means dz is also 0. So, this will not at all exist. So, what we will be left out with? Dx and dy. So, what do you have over here is dr vector is dx times of I plus dy times of j. Now you will have to take dot product. So I into I, j into j. So what will be the function f dot dr? Y plus 2 times dx plus 4 times dy. So this is the expression I need to evaluate. What is the equation of OA? Y equal to 0. Equation of AB, x equal to 2. Equation of BC, y equal to 2. And equation of CO, x equal to 0. Okay. So now we can evaluate the 4 regions. Now go on to the next slide. Okay. So this is going to be our boundary. Now we will evaluate the curve one by one along OA. What is the name of the line OA? Name of the line OA is y equal to 0. When y equal to 0, what will happen to dy? Dy will also become 0. Y equal to 0, dy equal to 0. So what you will be left out with? Integral 2 times dx. What is going to be the variable here? X. So x has to vary between, what is going to be the direction of variation? Varies over here. This is my x. This is my x. So x varies from x varies from 0 to 2. So this is going to be 2x between 0 to 2. So this is going to be equal to, so 2 into 2, so that makes it as 4. Okay. So next line is going to be AB. Name of the line AB, x equal to 2. Dx will also be equal to 0. So when I substitute dx, it will become 0. So what you will be left out with? You will be left out with 4 times dy. So you'll have to integrate 4 times dy. What is going to be the limit? You'll have to move in the direction of dy. So when I move in the direction of dy, y varies from 0 to 2. So you have your y varying from 0 to 2. So 4 times of y between 0 to 2. So 4 2s are 8. So second line got. Now move on to the next line. So what will happen over here? My next line is going to be equal to y equal to 2. So what will happen over here? Y equal to 2. So when I substitute y equal to 2, what will be dy? My y equal to 2. So dy will also become 0. So dy will become 0. Y is 2. Already there is 2. So along the line BC, I will be integrating 2 plus 2 times dx. So it is integral 4 dx. What is the direction now? In the direction of dx. So you will have to move in the direction of over x. What is your x? 2. What is your x here? 0. Be very cautious. So where does it move? You move from 2 to 0. Okay. So be careful about the limit. Your x varies from 2 to 0. So when you apply, what will happen? This will become 4 times of x between 0 to 2. Upper limit is 0, lower limit is 2. So this is becoming minus 8. Now the last line is CO. What is the name of the line CO? X equal to 0. So what happens to your dx? Dx will also become 0. So this part dx will become 0. What will exist? You will have exist 4 times dy. What is the variable here? Dy is the variable. So you will have to check for your y limit. Where does our y vary? Y varies from 2 to 0. This is the direction which we move. So the lower limit for y is 2, upper limit is 0. So it is 4 times of y between 0 to 2. So it is 4 times of 0 minus 2. So it is minus 8. Now this is the addition of all the 4 terms. So what you have over here? 4, 8, minus 8, minus 8. When you add integral along C, so it is 4 plus 8 minus 8 minus 8. Plus 8 minus 8 cancels. So it is 4 minus 8. What is 4 minus 8? It is minus 4. Okay. So you have the answer to be equal to minus 4. So the final answer for your right hand side is going to be minus 4. So this is going to be my left hand side. So left hand side is got. Your right hand side is also got. So what is happening with your right hand side and left hand side? The final answer has been got as 4. So hence we conclude that the Stokes theorem has been verified for the given problem. Okay.